I have moved the hand drawing we made last time about how boron 2s and 2p mix in B2. It's in the lower left, and in the upper left is the original B2 first order diagrams. I have labeled our new hand drawing orbitals that you can see on the way left phi A, and so phi A is also now going to be shown in the first order diagram. There it is in red at the bottom. Then comes in blue, phi B, now in the first order diagram as well. In green, phi C, and then at the very top in purple, phi D. So both drawings now have phi A, B, C, and D. Okay. And now we're going to go on to the second order diagram, MO diagram. We're about to make the second order MO diagram. And as we can see, I'll draw in black. I'll draw, again, that very bonding orbital that phi A turns into. I'll put it right here. There, that's the very bonding orbital. And it came from going down from phi A. Then we have the, we'll see what happened. That was the very bonding orbital. We'll now look at what happened to phi B. Phi B became a non-bonding orbital. So I'm going to show that here. Phi B. Let me get the shading the same. And again, it came from this orbital over here, going down. Then we have phi C. Phi C went from bonding to non-bonding. So it went up. Here it is, non-bonding. I'm keeping the phasing the same. It went up. And let me draw that a little better. It went up. And then finally we have phi D. It also went up to make very anti-bonding. And orbitals have mixed as advertised. The variational principle told us to make the bonding orbital as low energy as possible. And now we have a very bonding orbital lower in energy than phi A. The variational principle told us to make a very anti-bonding orbital. And we now have a very anti-bonding orbital higher in energy than phi D. The mixing worked exactly as advertised. So I've now drawn the four orbitals. We see where they came from, and I'm going to erase these curved lines that connect it. These are the original orbitals, and we're now about to draw the pi orbitals, which did not mix previously. And you can see here is one of them. The pi orbital, one of them is right here. And so unmixed, they just travel over unmixed like this. And here's the other pi orbital unmixed, which I'll draw here. A little too high here. Still too high here. That's because everything is moving. Here. And I'll draw them. There's the pi star. And the pi orbitals don't change in energy. We can now draw let's get rid of those lines. And we have, this is the second order MO diagram based on the mixing of the first order MO orbitals. And we have 1, 1, then comes the pi, 2, 1, 2, and 1. This is the B2 second order diagram. And we have B2 has 6 valence electrons, 2, 4, 5, and 6. Is B2 paramagnetic or diamagnetic? Put it in chat. B2 is paramagnetic, and it is traditional, although it's not where they came from. It is traditional in the second order diagram to draw the original AOs on the left and right side. I will do that right here. Here are the original AOs. I'll put that in 1, 2, 3. Oops, in the wrong position. Here I'll put the original AOs. 1, 2, 3. There it is for the one on the left. And here it is for the one on the right. Here's the 2s. Similarly, I draw on this side. I draw the 2s and the 3 original 2p's. And the tie lines are terrible. I hate drawing them. I'll just draw a few. This came from 2s and 2p. It came from 2s and 2p. This came from 2s and 2p. This came from 2s and 2p. And so forth. The tie lines are just everywhere. And that is the second order MO diagram. This is the second order orbital diagram, and this is the MO diagram for B2.